for that introduction, Kevin. Very well done, like always. All right, we're going to solve systems by graphing, okay? Do you guys know what a system of equations is yet?
Multiple.
I don't think so. Oh, multiple. You actually got it right. But I don't think we've done it yet, a system of equations. So we're going to solve the systems by graphing, and then we're going to talk about some special types of systems.
Ooh,
All right, a system of linear equations is two or more. Very rarely is it the more. For our purposes, it's always just going to be two. Linear equations in the same problem, on the same graph, two linear equations at one time. Okay? Any ordered pair in a system that makes all, usually it's going to be the word both. Let's change that. Cross off the word all, guys, and change it to both. Because we're only talking about two. Any ordered pair in a system that makes both equations true is a solution. That's what we're looking for. The solution of the system of linear equations. All right. Everybody put your arms, both your arms, put your pencils down for a second. Put both arms up in the air like two linear equations.
Like touchdown?
Everybody always goes touchdown.
No, it's because Henry is.
Hey, let's put some slope, put some angle on them, and let's intersect them. Okay? This.
How?
I'm gonna go plus.
No, not right now.
Safety.
Let's go intersection. Okay, this is what happens like 90, 95% of the time. They intersect. Now, here's my question. If you have this situation, and they intersect right here where your arms cross, is it possible for them to intersect at another spot?
No.
Yes or no?
No.
Definitely not. And there's always one kid that's like, what
Unless they go around the world.
Around the world over in China, they're going to hit again. That's Henry's response. No, that will never happen over in China or anywhere else. Okay? They are intersect. My hearing aids just went out.
Can you hear me?
No, that's kind of nice.
Now James also day two.
Big shout out to the fourth period.
Going strong.
The food is stars.
All right, big shout out to fourth period.
Water stars.
Sure, I'm in.
Day two.
They feel the need. Remember these are just 8th graders that feel the need to say strange things. All right, hey, Matt. So, here's my question to you guys. As we go through this is what happens 95% of the time.
Yeah.
Is it possible for two lines to never intersect?
Yeah.
Yeah.
Put your
like that.
Put your arms like you think two lines would that would never intersect.
Henry.
Oh. On the same plane, Henry.
Like this.
They would have to be, what's the word, guys?
Or this.
Parallel.
Parallel.
Or this.
Or this. Or put an angle on them. Put some angle on them. Okay? What do you think, you guys already know the answer to this question. What's true about these two lines?
There's no solution.
It's no solution, but what do they have the same?
Same slope.
They have the same slope. Because they're parallel. Okay? So, here's how we're going to do this. Again, is there anything else possible that can happen? One solution, no solution.
All real
All
numbers.
real numbers.
It's something like that, but we don't say all real numbers.
Two solutions. Oh, like this.
Can't be two solutions. Okay, try to put your arm on top of each other.
Oh yeah.
What if it's the same line on top of each other?
Infinite.
All real
Okay.
numbers.
It's not all real numbers because the stuff over here doesn't count.
Infinity.
An infinite number of solutions.
Oh man, I said it. You guys heard me, right?
I heard you.
All right.
I said
All right, let's do this.
Yeah. Okay.
Step-by-step instructions on how to do it. Okay? You're going to graph your equations. You guys are all pros at graphing. You're going to find the point of intersection. Use a straight edge, and what you're looking to happen. Everybody put your little pencils up in the air like in front of their faces. Okay? You graph one line. Easy. You graph the other line, and you know how when you graph the line, you kind of count the slope and rise over the run, and you want that second line to boom, jump right on top of the first line. Okay? We're going to do that. This point is your solution. Okay? And then you can double check your work. We'll talk about that after we find our solution. That's pretty easy. But let's do this. All right. Solve this system. Y equals 2x minus 3 and y equals x minus 2. Two linears, both in slope-intercept form. We made it easy. Henry, what's the slope of that first line?
2.
What's the y-intercept?
Negative
-3. Jot that info down and everybody graph that line. I'm going to do it in blue.
Oh, this is the extra credit.
Use a straight edge.
Oh, they're not inequalities.
They're not inequalities. We're not shading yet. We're going to do that eventually.
That was the extra credit.
That was the extra credit. 2 over 1, 2 over 1, 2 over. Notice I do it a bunch of times because we want that second line to jump on top of the first one.
Oh,
What if it goes over?
What do you mean, what if it goes over? That's a good question. Let's say it another way.
It goes through. Oh,
Boom! It's going to jump on top of it eventually. All right.
First one.
Al, Cubon, what's the slope of that second line?
Yeah, first one.
What's the
First
y-intercept?
one works.
Okay, -2. Okay, a slope of 1. Okay, it's going to jump on top of that first line in the very first move we make. Okay, it doesn't happen on the first move usually often. So watch, here's what we do. Goes up 1 over 1, boom! Then I'm going to do it a couple more times.
Startled me. That's the best line ever.
No, that's a crooked line. That's not a very good line at all.
How'd you make that first one?
those of you at home do not make
Wait,
fun.
who said that? How to make the first what? Line? Okay, what's the
No,
slope?
I meant it's straight.
Got it. Circle the point of intersection.
I got
Great
the
habit
extra
getting
credit
it.
right, I think.
Yeah.
And
It's 3 times.
somebody tell me the coordinates of that point.
You're not looking for a certain point.
We're looking for the intersection.
One
Quinn
negative
Livin, what's the coordinates of the intersection of those two lines? 1, -1. Remember x, y, guys. X goes first, y goes.
Henry, on the
one,
extra
-1.
credit, it was the whole region.
People aren't done yet.
Hey,
All right,
Just kidding.
next.
Sarah,
Hey,
I
next
know how
question.
to do it.
I love
How can we?
talking nonsense.
Hey, listen. How can we make sure 100% that we have the right answer?
Plug the values in.
Into where?
Look at the answer.
On both equations.
Well, job, Wilson. Hey, what we're going to do is we're going to take this point and we're going to plug it into both equations. Watch this. Y equals 2x minus 3. So -1 equals 2 times 1 is -3. What's 2 minus 3?
-1.
Boom. Checks. Check into the other one.
Do you have to check
-1
it on the homework?
equals, please,
Wow.
1 minus 2. What's 1 minus 2?
Negative
-1.
one.
Boom.
How did you get those?
No, what?
How'd I get these?
Oh. Yeah.
Okay, I took the first equation,
Yeah.
and I took what we think our solution is, Nico, and I plugged those values in. Remember, a point is x comma y, so I took the -1 and put it there.
Yeah.
Okay.
2 times 1 is 2. And again, you will be able to do most of this in your head. You would, guys, check them. Make sure you're getting them right. That's what you want to accomplish. You'd be silly not to do that.
Maybe it's just because it's the first problem, but are the 2 points always like so you know how we plugged them into both equations and both were -1 equals -1? Are they both going to be that? I mean, I know it's
I
not
think
gonna
so, because if they're in slope intercept form, it's y equals and y equals, and then y will always be the same number.
Be, yeah, 'cause
Is
it's
that a problem?
okay, so it's always going to be the same, but not -1 -1.
But it's the same number, correct. All right, now there's some new words you guys need to memorize.
Yeah.
All right. If the lines intersect, like they did in that example, how many solutions are there, guys? One solution. We call this system consistent. Put an arrow pointing to the word consistent. Consistent means at least one solution. And I always abbreviated solution, guys. SOL apostrophe N.
No, salute.
Solution.
Salute.
Okay, that's what the word consistent means. And it is independent. Okay, I think you have some questions like that in your homework. We will practice doing it in your homework. I'm not sure if we're going to test you guys on those words yet because they're tricky. Independent means
Does that mean it's solved for y?
exactly one solution. Does what mean is it solved for y?
Independent.
No. Independent means exactly one solution.
Well, now I know.
All right. Next, if the lines are parallel, here's the special cases. What's the same
Slope.
slope? They have the same slope, and there is, what do we write as an answer? No solution. You have to write that. Don't just write two parallel lines.
I'm good.
Okay? We call this system, it's the opposite of consistent.
None.
Not non, another prefix.
Inconsistent.
Inconsistent. Inconsistent. Which means, inconsistent, put an arrow pointing to it, which just means no solution. I don't know why they just don't say no solution. They have to make it inconsistent. But you'll do more with this, guys, in Algebra 2, with this whole consistent, inconsistent, dependent, independent, stuff like that.
So inconsistent.
All right.
Inconsistent.
Now, what if, oh, go back to, everybody put your arm on top of each other. Okay? Let's pretend you graphed two lines and the one was right on top of the other one. Tell me some things that would be true about your lines.
Same slope.
And same
Same slope.
And same what?
y-intercept.
That's same y-intercept.
Same line.
What would it look like, Al? What would the two lines look like?
One line.
Parallel.
Like they
One line.
What would the numbers and the x's and the y, what would everything look like?
Same.
Same.
it's the same.
They'd be exactly, you'd be a moron not to be able to tell that it's the same line on top of each other. The lines would, if you solve them for y, they would be exactly the same. Y equals 2x minus 1.
Doesn't have to be the exact same equation because it could be like 6 minus 2.
But when you put it in the same form,
Yeah, I know.
then it will be,
But,
that
right
is
when
how
you
they try
see
to trick you.
Right when you see it, it doesn't have to be the same.
Yes, that's how they try to get you, Al. When you see it at first, they're not going to look the same, but when you solve them for y, they're going to be exactly the same. So, if the lines are the same, okay, how many solutions are there?
Infinite.
There are an infinite number of solutions. You have to write that down. Infinitely many solutions, or infinite number of solutions. Don't say all real numbers, because that's not true. Everything is not an answer, but there are an infinite amount of them. We call this system consistent, because there's at least one solution, and dependent, which dependent means infinite number of solutions. That's what dependent means, infinite number of solutions. All right, so only three different things can happen. One solution, no solution, infinitely many solutions. That's it. You can't have two solutions. Doesn't work. All right, let's try a couple of them. All right. We have 4 of them on there. Jot down the slope of the y-intercept, graph them using a straight edge, try to get that second line to jump on top of the first one. Who wants to try A up here? Olson, give it a shot. Sonali, you got B. McNulty, you got C.
D.
Henry, you got D. Briggs, you want E?
Oh, there's
You got E. And then F is a tough one. You got clear fractions and a bunch of work. You want to try it?
Sure.
All right. You want to come get a check by me before you go up there and do it? All right, let's see what Olson can do. Y-intercept's -4, knucklehead.
Dang it.
Nice job, Olson.
Work,
Hard to draw a straight line freehand, isn't it?
Yeah, up here it is, but not on paper.
Wait, what? +3. You gotta say the word.
Boo!
You gotta say it.
Boo!
Boom.
Solution.
-2/3. So just fix this part. 1, 2. No, 3 it lands right there. So just fix this one and you got it.
solution is 2 times 2.
How can you check it?
Oh yeah.
Do it a different color.
Alright, so solution's in green. So 2 equals 3 times 2 minus 4. 2 equals 6 minus 4 is 2. 2 equals 2, that checks. And then 2 equals negative 1/2 or 2 plus 3. 2 equals negative 1 plus 3. 2 equals 2, that checks 2.
You're a man.
Can I delete all this?
Well, I got a call. Hello. Yes.
Dude, you are the man. Dude, you are the man.
Okay. Okay. Where'd you call me from? Oh my God. Is your computer in
Dude,
your
I
phone?
just got
Everything okay?
all
You okay?
this. Yeah. This is Alex was saying. Yeah. Let me see this.
Where's your phone at? Nice job, Olson. Next up is Sean Sedano.
Hey!
Ooh.
Put it down.
Okay, I'll go there now. Alright, feel better. Bye. What's up, Mr. McCall? That's my wife, guys. Some strange phone number. Should I be worried?
Yes.
She got me tripping.
But no, but when we write it, it is inconsistent with the, what's the solution? No solution. Not inconsistent, right, no solution.
Oh.
No, not yet, not yet. Yes, you did it right, nice job, that's what I got here. 0, 3, good job. 1 for 1, so the answer to the first one. All your lines.
Yeah.
Stop, right. So the first one was Olson was 2-2, right?
Yeah.
Okay, keep going, Stella. You're doing great.
This is just gonna take forever.
Mr. Fancy has left the building.
Is it negative?
Yeah, you guys. Help us.
Needed
We're held captured. He's back.
84.
Time for the living.
No. Remember A.
Really? What's that coordinates? What's the x value? What's the y value, Sean? You can do this.
X value is
Of the intersection. Circle it.
Don't make us go over 2, Sean.
Ooh.
Yeah, circle it. Okay. What's the coordinates? That's not -3, -3.
oh, it's negative 3.
Negative 1.
Right. -3, -1. Great job. All right. To save time, we're not going to check it. Check it while you're doing your homework or whatever. All right. Next one, we got one that's in standard form.
Whoa, 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 what do we do?
Henry, what are you doing?
M equals B equals. Remember our little trick?
Boom.
Negative A over B. So that'll be -6. That'll be +6. 6 over 2 is 3. I like to write it as a fraction because it's the slope. And B, we got our little trick. C over
It is the same
B.
line, so what do we
All
have
right.
for answer?
That'll be 2.
You got it.
For our next one, easy, it's in slope intercept. So that'll be 3 over 1 also. Uh-oh.
Whoa.
Uh-oh. What do we do? And y-intercept is -2. We'll
Whoa.
graph that one first, -2. And then we'll go up 3 over 1. Again. Do-do-do. Yay. And y-intercept is 2 on the other one. Up 3 over 1. Over 1. Down 3. Okay, okay. And then
Got the slope on
Hey, draw your lines, my friend.
it.
Oh,
-6x.
No, straight edge. No straight
it
edge.
doesn't work?
No.
Why not?
No, because you tap it. Stuff happens.
just do a freehand. That's the best you can do.
No, nice.
My second one is pretty good.
Yeah.
So tell me what you know about these lines,
These
Kev.
lines are parallel, which means they never will intersect. There's no point to graph. That'll be a no salute.
Good
My
job.
friends.
Good.
And I'll finish the word. Shut.
Kevin,
You
you're
got
on
3 over 1.
deck. You got on deck.
That's the equal sign. I'm equals.
In the hole.
What are you doing?
You gotta
Put it back.
When I did
Don't
this,
erase
You did
this
something.
stuff.
I'm in the hole. You're on deck.
Guys, let's go. So, guys, for letter C, does everybody agree it's no solution?
Yeah.
All right. Let's see what Henry does for the second line.
I shake the air around. In the face.
oh yeah, I
No.
did.
Yeah.
You understand what you're doing now?
Yes. We hunt for food first. And
But be careful with your negative slope, Henry. Draw your line. Very nice straight line, Henry.
restaurant.
Boom!
And a great boom, too, by the way.
Great boom.
What word are you going to write down next to your x equals -4, though, Henry? Get in that habit.
Bucks.
Write it by the equation. There you go. Guys, write down bucks or hoy by your equation.
0.4.
That was great, Henry. Nice job.
Terrific job, Hen.
All right, go to the next page.
Wait. Was it actually?
Excellent.
Oh, I'm in the hole.
All right, let's see what Briggs does on E. E's a special case. I'll tell you that right now.
Yeah. Okay, so for this first equation, you divide it.
Oh my god.
Henry.
That is not a real place.
Oh wait, no.
That was a really good erasing.
What?
Cuban.
You got it right.
Negative 3
Oh yeah, I wrote.
That's an equals.
Oh yeah.
Oh, look at that.
And then,
Caught his mistake. She get extra credit point.
Way to go, Olson.
Hey, these are the same lines.
How do you know? Nico, how do you know?
It's all, or is it,
Because
and,
the
what's
slope
it called?
of the y is the same.
Independent, right? Inconsistent, right?
Go down 3.
No,
We went down 2. There you go.
oh yeah, I wrote
Infinite.
pictures of that line.
number of solutions.
Where?
Infinitely honey.
Oh wait, why did?
You're right.
Yeah, I was doing the graphing.
Mr. Fancy, on a test, have you already like found out that it's
you're weird.
all reals or
No solution.
no? Yeah, can you just write it?
No, you got to graph. It's good to practice graphing.
So what are we writing? Not all reals, but what are we
Bingo.
writing?
Wait,
Wait, what are we writing things like that? Not all reals.
and
What do you write down?
Oh, yeah, infinite.
Aaron, explain.
Consistent.
Well, both of the lines are the same line, so they're like overlapping.
So infinite amount.
So what's the solution?
Infinite number of solutions.
6. You need more space.
Yeah, you got F.
Great job.
Beyond.
Infinite number of solutions or something like that.
No way.
All right. Now the difficult one because you got all those fractions. Guys, what should you do first on?
Clear fraction.
I would clear fractions.
Clear them all out of there.
Nice job.
Nice job.
Use a different color maybe, Al. Nice job, Cuba. Say it.
Boom.
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 Do
Explosion.
your best to draw the lines.
Ooh.
Draw the
Explosion.
blue line. Circle.
Explosion. Boom.
Boom.
And label your answer.
Loud noise.
What's the solution, dude? 0, 3.
You got the right.
That was the one solution. Alright. Other people think it's just a sneaky way to make you graph 2 linear equations at one time.
Yeah.
That's all it is. That's all it is. You guys can do this. Everybody say signing off. Goodbye.
Bye.
Goodbye.
Hello.
Adios.
Are we doing inequality?
Nico.